Hello, everyone. Welcome to J Champions Conference. And this is our final day, final talk. And who else we have? We have Mary Grigleski, who is a Java champion. She's my favorite person, by the way. And she's a very famous developer advocate. And you have to hear from her all the things. And she will talk about event messaging and streaming with Apache Pulsar. So give it a stage to Mary. All the best.
Thank you, Neha, and thank you for Neha's baby too. Neha's 2 months old baby is with her too. So thank you. And thank you too for the Dublin Jug and Barry and Thomas and everybody. Thank you. So yeah. Okay, so let me start this talk. So I'm at the Dublin Java Users Group, and really such an honor to be here. And thank you to everyone here who's in the audience, although we cannot see you, from the screen here. But yeah, trust me, yeah, they are, a whole group of people here. So thank you. Thank you, everyone. So today, my talk is about event streaming and messaging, or event messaging and streaming with Apache Pulsar. And just to let you know, some of the audience here already heard actually my part two of the talk, which I hope to do year. But the thing is, too, we're getting back to the basics. So this particular session is really more introductory about event streaming and with Apache Pulsar. So, all right, let me kind of go over here. Okay, so before I start, and if anybody would like a copy of this slide deck, this is the bit.ly link and also the QR code. So I'll leave it on here for a little bit, and also waiting for folks to get get the picture first. So, and even if you missed, don't worry about it. I will be sharing this with the organization and with Ken too, with the team. So, all right. Okay, so who is Mary? Really quickly, I'm a developer advocate at DataStax, which is a company that's major thing. The flagship thing is about Apache Cassandra, and they have a managed cloud platform called Astra. And right now, too, or a year and a half, 2 years ago, a company also started doing streaming, event streaming, and has adopted Apache Pulsar, the project. And that's the theme of today's talk, is really about Apache Pulsar and also about event streaming. And I'm based in Chicago. I'm also a Java champion and president of the Chicago Java Users Group. And so you are all welcome to join me to the Chicago Java Users Group. My background, though, I have over 20 years or so of development background, engineering hands-on, so I understand what it takes, right, to become an engineer, developer in the real world, in an IT shop, and doing production, implementation from design, architecture, all the way. So that's my background. But really, I've been enjoying being a developer advocate when I joined IBM 5 years ago, too. So, yeah. Is everything okay, Neha? Yeah. Okay. And okay. Okay, let me go to the next slide. Okay. So this is just another kind of expression about my background here. So I won't kind of dwell on this, but just from my company to DataStax developers, this is my, kind of my profile. So, okay, so let me then start by giving an introduction or an agenda of today's talk. I have to kind of make some assumption too. Maybe not everybody has come, with an, experience working with events, event streaming, event processing, all of these things that are events that can be so confusing to everybody. So I want to spend a few minutes kind of giving a bit of a background. So pardon me if you already have heard about these things or kind of a repeat, but I hope to also introduce the concept to those of you who are completely brand new, or even, you're just curious to listen to what events are all about. And then I'll introduce to you event processing semantics, pops up, and the queuing. And also to why event streaming and why do you want it, right? And what are the alternatives? And then I'll introduce to you Apache Pulsar, and also Apache Zookeeper and Apache Bookkeeper. Also highlighting a couple of developer features that Apache Pulsar brings. And also to why Pulsar, how does it extend the capability of what Apache Kafka, cannot do. So, So first, let me start by talking about the many facets of computing events. But first of all, too, like I really, to me, I find the topic of event computing to be very fascinating in the sense that if you kind of start thinking about it, okay, let me put it that way. I think when we first start learning things, nobody really take the time to say what is it that we're trying to do. So that's the reason why I thought I spend a few minutes just talking about some basics about what is an event, and kind of generically speaking, right? What are we trying to capture in here? Essentially, too, I wanted to say let's get back to ground zero event, right? Without any context to it, it can be an occurrence. I took this from Merriam-Webster, the dictionary, something that just happens, an occurrence. So now then bring this events into computing, the computing world. It can become quite fascinating if you think about it, right? It's basically, if you describe it as, if you kind of have draw a picture out, I think it's essentially four dimensions that we're talking about, essentially a place and time. So the three coordinates of x, y, z, if you are more math inclined, right, it's a dot in if you plot it in a three-dimensional space-time kind of thing, or just space, and it will be three-dimensional xyz coordinate, and then is in the time scale it becomes more and more interesting. But kind of this is what I kind of take from the theory of relativity too. Okay, so without getting into too much theory, but I find it to be so fascinating because events can happen, but if you think about it too, even in real life, it can be the birth of a baby is an event, a musical event, a sporting event. But if you think about it, it's immutable. I mean, something that happens, it happens like that. You can't go back in time and erase it. I think it's fascinating to me, right? And not just computing. But okay, so let's get back to some reality, right? Not just like thinking about this kind of philosophical thing. So we're kind of talking about events in computing time. And why is it important? Because we're capturing data at any moment in time. And that's what we're trying to do. And to me, I think it's just fascinating. But okay, so kind of, I know I've been like rambling a little bit, but it just excites me so much because I'm thinking, right, if you have something that happens, you need to capture it. And how do you capture it? It's not an easy thing. And not only that, events don't happen synchronously. So that kind of describes like how when we first start learning about doing things eventfully, it's actually the intuitive way. It should be done that way. But yet we start learning programming to do things in a more structured fashion. We simplify things. We're doing it synchronously. We're talking about block calls. We're kind of talking about we want to do something. We actually have to issue a command, and then the command get into some statement, right, when we program. And then we do, let's say, if somebody has learned also basic too, and that's what I first learning, right, basic coding, you're doing like, oh, let one equals, I think something like that, right, and one equals two. But in the meantime, when it's processing, actually then the processing will have to wait. It's a very synchronous way of processing. And that's what we're used to. And I think that's why too it makes us harder to understand how to do event kind of type of programming, because it's really different. We're dealing with asynchronous style of processing. We're dealing with events that can happen at any time. There's no structure to it. There's no structure to the data itself either. And so all of these things, how can we kind of make sense and yet being able to manage that what seemingly can be chaotic, because you can have different events happening at different time asynchronously. How do you even track it, right? And all of these things. And so those are the challenges in doing event kind of computing. And so let me then, for sake of being, able to structure this whole topic together, is basically an alphabet soup of event computing. Because when I first kind of approached event, kind of thing, and I realized that there's event processing, event streaming, event messaging, and event-driven architecture, event sourcing, event storming, all of these things. And not only that, then we're talking about serverless kind of scenario of doing things like serverless apps, stateful microservices. They are kind of naturally bringing in an way of doing things too. And it is very true, microservices doesn't have to be event, kind of using the event way of doing things, but it's actually a natural way of doing things in microservices is to do things in a more eventful type of way because of how, small size it is, and it's how decoupled it should be, right? So just a very quick kind of explanation too is that all of event computing too is really dealing with data, the changes in the state as it travels through space and time. So I just want to kind of quickly iron out a little bit. I'm talking about event streaming, event messaging today, but they are not the same as event processing and not the same as event sourcing or event storming. All of these things, they all have their own definition within this context of event stuff and event-driven architecture, for example. And then also complicating things further, that I'm sure you've heard of reactive systems, which actually I advocated for. I realized that if reactive systems, or at least how I've understood it, is that, in the abstract world that we live in, is really more about reactive systems in my mind is a bit more on an abstract level. It leverages on all of these event kind of approach. Event messaging, event streaming as you're learning is a bit more dealing with the mechanics, the techniques of these things. But reactive systems is a little bit higher level because you rely on some event kind of techniques in order to achieve the purpose of being responsive, being resilient, and being, elastic, for example, things like that. So, at least this is how I kind of sort them out in my mind. So I sometimes like to sort things out in my mind so I understand and I know I'm doing the right thing. So that's why I thought it's important. And another thing too is about event storming. And in fact, maybe some of you have done maybe event storming before, but event storming is more about, doing like design phase. When you're doing domain-driven design, you're kind of storming is brainstorming. I think that's what it's referring to rather than any kind of event kind of processing. So I just wanted to kind of bring this up because it's confusing enough. And now then let me get into like talking about event streaming and processing. So essentially to event, as we go back, a couple slides ago, is about the, each data point in the system. And streaming is really about an ongoing delivery of all of these events. But the thing is, we like to think of events, they change in time, but actually the thing is, it's more like plotting the graph in space, rather than, because each event that happens, it's there. You cannot change it. It's immutable. But the thing is, the stream is basically connecting all the lines of how the events changes, the data changes in state through time. So as such, too, a series of events can be referred to as streaming data or data streams. Now, the one thing I wanted to point out is that I've been asked this question is it the same as video streaming, audio streaming that, Thomas is doing it for us in here? But the thing is, too, is that for Apache Pulsar, it's not for video and audio streaming. The reason is that we're still dealing with data as they kind of travel through space and time, but yet it gets to the processing part. When you're doing with audio and video, you need synchronous way of managing, because think of your piece of music, you can't have different notes that comes out, kind of wrong, right? Or your movie cannot have different sequences, not the same. So it does actually, for audio and video, you do require the synchronous part of processing. But in this particular case too, like, for example, like more business processing, sometimes you don't necessarily require the synchronous side of things in order to process data as they come through too, or not as much. And now then, let's get into like complex event processing. So it is actually a set of techniques that, not only capturing the data, but it also provides more like in-depth analysis of these streams of data. So it comes to kind of dealing with, for example, fraud detection, dealing with machine learning. There are changes in your data. You need to constantly be processing the change of data and learning it, and then churning out new models to kind of describe your whole kind of algorithms, for example, and you need to deploy it again. That's more dealing with complex event processing. So fraud detection, I also talked about a bit earlier too, with the Dublin group here, is that fraud detection, for those, watching this, and it's basically, you need to have processes that are monitoring. For example, in your bank account, you want to make sure there are no suspicious changes in your data as the day goes on. You realize you saw some processes, something happens in debiting your account. We're here in Dublin, somebody is debiting your money out in Saudi Arabia, for example. Then you want to have some way of recognizing that problem and immediately notifying those that are affected, right? So those kind of, all these things are really about complex event processing. So, okay. And now then get a bit more back into the messaging kind of side of things. There's actually a difference between event-driven and message-driven type of processing or kind of messaging, I should say. So event-driven is dealing with the sender admitting the messages, and then it sends the messages out. So we'll be, it doesn't care about who is going to receive the messages. And it's basically, essentially, too, on computing terms, is that I don't care about the address of where I'm sending the messages to. I'm just going to send the messages out. And then interested subscribers will have to subscribe to the messaging and essentially topics, right, in a pops up system, and then be able to kind of receive, the messages when they come. And then for message driven, though, is that your sender and receiver, usually you have to know each other address too. So that's kind of the differences between event driven and message driven messaging. And then there's also kind of topics too on, there, I've been asked too, like, if we don't use, event driven approach or event approach, what can you do? So now essentially too, events are not all brand new, as we know. And, even like back, say, like when telecommunications first come out, right, telephone system, they were actually using more a model is that's actually actor model from, as some of you may be aware of Erlang, that language, and they are actually using an actor model for doing kind of a mailbox like send and receive kind of approach. So that's already kind of done in the past, but that's kind of a bit of a different style of eventing. Okay, so then we're kind of like talking about, what if, some cases, it's not relevant to using event-driven type of approach, and certainly, right? For example, you have like batch processing that would be kind of like juxtapose the event-driven approach. So that would be batch processing. For example, if you're working for a company, then you have an employee system of record, and there are changes in your employee records. And so those kind of set of data can be batched up, right, at the end of the day. And at the end of the day, you batch it up and send it to for further processing, for maybe storing them into a system and doing processing. So in other words, what I'm bringing this up is that like event-driven approach is not appropriate for all kinds of situation. It is certainly has its place in kind of in the computer place, because it provides real-time kind of benefits too, and real-time processing, all these things. But it's in some cases too, like batch processing is just as fine, right? If you don't need the data right away. So that's the differences. Okay. And then now then let me move on a bit then into the event messaging semantics and patterns. So over here too, we are talking about pops up streaming. Very often too, when we talk about streaming, and we kind of would be talking about the pops up publish, subscribe, or producer consumer pattern. It is a design pattern. It doesn't dictate how you should implement it. So there's no implementation details, and architectural pattern that we're using, and very often is used in streaming. The reason is that it makes use of it. It basically is a loosely coupled type of architecture in which the clients, whether you're producing or receiving end, they are all detached from the system. They all have their their individual components, but you need to the ones that are sending messages to the publisher, you send the data to a topic, right? So topic is what identifies messages, the messages, and basically topic or routing channel. And then broker, usually you involve a broker. Broker is like the middle agent that would be there, that owns the topic, and then would be receiving the messages as they're being sent to a topic. And then from there, then it would deliver the messages accordingly to those who are interested in the messages by subscribing to the messages, to the topics or the channel. So as you can see over here, it's like you can have actually multiple producers that are producing to a single topic, or you can have one-to-one, and it's just different ways of configuration depending on how your library, it's kind of broker is being implemented too. And then on the subscription side too, for example, like Pulsar too also has different types of subscription mode too. But essentially, it kind of relies on a broker in the middle to be the ones that's receiving and delivering messages and owning the topic of these. So that's pops up. And then there's also message queuing, another kind of semantics. Is basically is a form of also asynchronous style of service-to-service communication. Your sender receiver are also very much detached from each other. You don't need to be like so much aware of being attached to each other. So it's a very like lightly coupled, so to speak, right? And there are also different ways of implementing message queues too. But very often too, what happens is that messages will be sent to a queue. When they queue up too, it's waiting to be picked up. But once it's picked up, usually too, then the messages will be deleted from the queue, and that's how it's usually being implemented. So the benefits, as you can see, pops up, and also queuing too, they are really good at kind of helping with asynchronous style of processing. So that's commonly used. Okay, so then let me kind of move on a bit into event streaming. Is basically a step beyond just doing the event messaging part. So what is driving the change? Why do we need event streaming, right? So the one good benefits about it is that it helps in processing data in real time. Let's say, for example, right? An example could be, well, let's say here, I think in Europe too, it's very commonplace. Folks are very interested in soccer, or even Americans are football and all of these things. So it can be actually used for, like, say for example, you can be measuring players statistics as it happens. So you can actually leverage on a event streaming type of platform, because you can have maybe different devices, and which is something I've already heard, is that different athletes could be wearing devices and measuring their different kind of muscles movements and all these things, and it can be reported immediately to a server that's analyzing their play, maybe like how much force, like in a player that's kicking a soccer ball, whatever it is, right? And then they can actually, based on the data, they can constantly be making recommendations as to how they can improve their play, right? So all these kind of real time is an example of such. Basically, what I'm trying to say is that basically the imagination is in your side, that you can imagine how you can use this technology to create like new possibilities, is what I'm trying to say. And then there's also another need, for this technology, basically is use it to build like data pipelines. This kind of approach too is good for, especially for artificial intelligence and machine learning type of applications. And essentially too, you can, for machine learning, for example, machine ML ops type of scenario, essentially you want to analyze the data as they come. And then when they come to, you want to immediately learn about the data and then update your model. Immediately too, you want to also deploy this model into your production system. So being able to process like huge amounts of data coming in, and in high speed and immediate and in almost real time, definitely you can consider using an event streaming approach. Although I have also heard too, I've spoken to some machine learning expert. They are saying that they are still not using event streaming platform, because the amount of data that they are processing is surely really, really huge, right? So any kind of things that happens, they're capturing all of these data. So I think there may still be some time for event streaming platforms to really get caught up to the true needs yet. But definitely the potential is there. Okay, and then there's also then another need would be to help with scalability too. With this kind of system being pops up, you basically can increase the number of brokers, or increase partition of your topics. It will increase throughput of your system really fast too. If you add a node into your system, you can immediately scale up really easily. So these are just some examples of why we want to consider using modern event streaming platform. Okay, so here too is just summarizing. It allows for to watch for the events with the system as it happens, and also too messages get sent to the system, and it's up to those who are interested to subscribe to the topic. So you're not forced to receive all events too, and you have the choice of what events to pick up to subscribe to, and then it helps you to make decisions in real time, not after the event too, and helps you to ingest high frequency of messages and respond back with low latency. Okay, this one too, actually, I already explained to the Dublin folks here, so maybe you, well, no, I'm just kidding. I was going to ask one of you to describe it. No, I won't. But let me kind of go, talk about this again. So basically, if we talk, comparing streaming versus not streaming, at the bottom here, if you look at it, is basically if you're not using streaming type of platform, for example, like an ETL system, extract, transform, load. You ingest the data, you persist the data then to some storage. Can be a database, can be a file system, or any kind of storage backend. But it involves I/O too, so it incur a cost to it. And then from there, you need to then select the data, and then do some querying, and that will actually be more expensive, so to speak. And then you continue, right? You process the data and you write it back to disk and like that. So that's kind of the older way of doing not non-streaming way of processing data as they travel through your pipeline, so to speak. These days, we have modern streaming pipeline that enables you to ingest data as they come in, and in memory, you immediately process the data, and that's what it makes it much faster. You don't need to write it to disk or upload to a file or whatever it is. You can do immediate processing, and then after you transform the data, you can write it to a sink. And sink is a place where you collect. It's like the destination of your processing outcome. From there too, you can actually build different pipelines as well, and then you can go on and on. So as you can see, naturally too, streaming and versus not streaming, naturally streaming will be faster. Okay, now let me enough talking about that. So let's get into Pulsar. So what is Pulsar? Pulsar is an open source project that's created by Yahoo back in about 2010. They contributed to Apache Software Foundation in 2016, and very soon after that, it became a top-level project in 2018. The reason is that everybody realized that we are now living in a cloud age, and we have to deal with design that is more aware of the cloud. And so that's how I think the really why Pulsar is becoming more popular is because of its ability to handle things in the cloud and being more infrastructure aware. So then it relieves, such as us, we're developers, we don't want to deal so much with the infrastructure. Let's face it, right? It's just, if you learn Kubernetes, it's going to be a lot of things to learn because it's complex within itself. So think of some system that already takes care of these infrastructural things for you. You can actually have more time to write code to meet your business needs, right? The algorithms is more the computing side. It's also more fun too, I think, in my opinion. So Pulsar has a cloud native design. To me, I like to describe it. Okay, so I actually got asked at a conference a few months ago, and they were saying that, would you describe Pulsar runs on steroids? It's like Kafka runs on steroids. And then I was thinking, not really, but I think I would say, Kafka has its place in space and time in history, in computing history. It handles distributed messaging really well. But the thing is too, one thing lacking, I think, in Kafka is that it wasn't designed with the cloud in mind. So it handles the computing side really well, distributed messaging, but it doesn't really worry so much about the cloud. So nowadays, if we need to expand things in the cloud, you actually have to rewrite a lot of your or redesign your partitions. How do you group your consumer groups? All of these things is kind of like takes a lot of time. But the thing is with Pulsar is that it's already been designed with the cloud in mind. So things are all cluster based. Also, there's multi-tenancy that it supports. And so essentially too, you can divide up all your data kind of very naturally into different units of processing. So it makes it already kind of naturally organized for your needs. And so takes care essentially a lot of infrastructural things for you. And not only that too, when you work with Pulsar, you don't have you have a choice of using different languages in the client API too. And it can be Java or Python or Go. These are kind of the primary languages, but then there are also like .NET, like C# client that you can write, and also community contribution like Rust or Scala, all of these other languages. And as such, it is open source, so anybody can contribute any kind of client APIs to it too. And another thing about Pulsar is it separates out the compute and the storage. So the compute side is when the broker handles all of the messages, delivery, collecting them, delivery, all of these things. But as far as messaging goes, we all know you still have to deal with the long list of laundry kind of basket of all of your messages. What are you going to do with it? So Pulsar says, I'm just going to have Apache Bookkeeper handle that for me, and I don't want to deal with it. It's like you owning a home and you don't want to do all the cleaning of all the different things, so you hire somebody to help you to do it. So Pulsar says, I'm going to have Bookkeeper do all of these things for me, and it's such, right? It's important work, but takes a lot of time. So I'm just going to delegate. So yeah, and then it is true too, I got asked too. But doesn't it add to more processing, right? To the whole kind of ecosystem? True, you add another process, it will naturally occur, or incur more cost. But if you kind of think of that, well, on the compute side, I worry about the computing stuff, and then separation of concern. So in the long run, especially have huge systems that are dealing with tons of messages and all of these, it's better off that you have somebody else to help you with managing all of the long laundry list of baskets of log messages. And that's what I think, right? So basically, the thing is that it outweighs, that the cost kind of outweighs, or actually benefits outweigh all of the costs that you need to put in by adding another process to it. And besides, Bookkeeper is a very good bookkeeper because it really knows how to handle all of these messages really efficiently too. So okay, so that's that. And then Pulsar too also has a feature of guaranteeing message delivery. So which means if your messages get sent over to your broker, rest assured it will be delivered. Even if your network goes down, something goes down, it will be guaranteed, right? Something goes down, when it comes back up, it knows that there's some messages in there waiting to be delivered. So it has all of these things that are guaranteed for you. And then there's also this Pulsar feature called serverless. It's a Pulsar functions. So essentially, it's a serverless functions framework. So it allows you to kind of write some complex processing logic, but not so much worry about the infrastructure. So basically, you can just implement that Pulsar function, and then you can plug in all of your logic. For example, your data coming through, you need to filter it, or you need to do some selection. For example, this is also where you can also involve maybe some database. Let's say you have data that comes in, and then you want to like, let's say a bunch of data coming in from like a form, a web form, right? Very common. And then from there, maybe you want to do some selection based on some information that's stored in the database. So then you need to connect with the database. You can actually use a Pulsar function and then have there kind of do some connection to a database, and you collect some data and then do any kind of select, join, whatever you need to do. So given that too, and being serverless, this serverless function is that it helps because you don't need to worry about, what if, I have increased processing, I have to worry about getting another, my server is growing again, and I need to add another node to my whole infrastructure. All of these Pulsar functions is being handled by the Pulsar runtime, the infrastructure itself. So it kind of gets to be quite nice to have. And then another feature is basically tiered storage offset. So or not offset, sorry, offloads. So this means that if there are messages that are hanging out for too long, it becomes cold, then it will be Pulsar will kind of sense it and say, well, you've been kind of occupying this space too long, you're not doing anything. I'm going to move you to offline storage. And you can set up an S3 bucket, for example, or some other kind of supported kind of external storage too. So that's kind of nice. Pulsar handles that for you too. So those are kind of like quick summary of what Pulsar can do. And let's kind of, this slide is basically describe a little bit and give you a bit of stats. The couple of graphs in here is showing that number of GitHub stars, number of contributors, and also like active, what is it? I can't even read that, sorry. But okay, so, but trust me, it is getting more popular now. So Apache Pulsar, this project, within the Apache community, it's actually 2021, it was like within the top 10 or even like top 5 projects. So everybody is recognizing it's important. So it is gaining in popularity. Okay, so who else is using Pulsar? So these are just a small handful of example. It is gaining in popularity. We're able, for example, in my company, we're also doing a lot of kind of POCs, proof of concepts too, with major companies too that are interested in this technology. So, so these are the ones. And Pulsar is different. Let me kind of really quickly look again, but these are basically repeat, right? A Pulsar component. Producer. So when you kind of take your Pulsar, what do I do with it? You write producer client code or consumer client code, and then you leverage on you send your messages to the broker, and basically have the broker help you, and you subscribe to the popular or the topics that you want, right? So broker is there as the serverless JVM process running, and it can be partitioned off and run different nodes as well. And basically, Pulsar can manage it all for you too. And then there's also the bookkeeper components that I already talked about. It handles all of the message stores. It helps with persistence. And then also Zookeeper too. Currently too, Pulsar is still using Zookeeper, but there's been also effort of also not necessarily requiring Zookeeper. So if you're interested in that, there's a spec out there that I believe has been implemented too. So that's just some information for you if you're interested. And here too, it's just about Pulsar itself. It takes on a traditional multi-node architecture. It helps, right, with horizontal scaling. It's already very natural that, horizontal scaling, meaning that you are adding some server to your infrastructure, some nodes and everything you need to grow your system, and all of these things too. Pulsar is already has built in and knows how to manage rebalancing all of your topics that are like, I have, topics is partitioned off into different nodes. And what if I add another node? I need to spread it out evenly. So those things are Pulsar will take care of it for you. So it's kind of a big thing, I think, because then you don't need to worry about it. As developers, we can focus on our business process more, right, than have to worry about infrastructure. And another thing over here is just another picture to show you is that there's producer, consumer. Basically, you can see that broker is like the central piece, right? This kind of like the center of everything is serving, right, everybody. And producer sends messages to the topic is owned by the broker. Consumer subscribes, to topics that are owned by the brokers. And brokers can be partitioned off into different nodes and all of these things. And Zookeeper will keep everybody, everything in sync. Essentially, all the metadata in the cluster, all the configuration, all of these things. In the meantime, broker also communicates with the bookie, the bookkeeper. Each one bookie is like each unit of operation that instances of the bookkeeper, and it segments off all of these log messages for its storage too. It's being more kind of evenly distributed among all the different storage units. So as you can see over here too. And then if you are interested in learning more about Bookie, you can kind of take a look at that. But to summarize too, it also supports this wall specification, which is write-ahead logging. System is very efficient, fault tolerance and low latency type of storage service. And it's very tunable too. So for message replication, all of these things, it is basically Bookkeeper is very sophisticated in managing all of your log messages, and is fast read and fast write, all of these good things. Here too, just a quick diagram of showing you how you can, kind of conceptually thinking of Pulsar is a unified solution for PubSub, for queuing, for streaming and message mediation and enrichment through function. For example, Pulsar function too. Now the queuing is interesting. I just wanted to point out how can you actually leverage on Pulsar, because you might be asking, well, it is a PubSub, a PubSub system, yes, but you can actually use it as sort of like a message queue, and I'll show you why. Because of a subscription mode called exclusive, you kind of effectively turn it into message queuing too. So I'll show it to you in a couple slides. But over here, this is just to show you that Pulsar is so flexible. You can use it as a bolt-on to any kind of, in your topology, in your system, you're running Kafka, JMS, RabbitMQ on-premise, all these things. You can just bolt on and add Pulsar in without intrusive, right? You don't need to really change too much. That's the idea. Okay, so some key differentiator I just quickly kind of show you is separation between compute and storage, which I already talked about earlier. But as you can see over here is that the nice thing about this design, is that you separate compute and storage so that, if you need to grow your whole system, they can be independently scale up and scale down. So then you need to like drag everybody around. You know how this is, right? I mean, if I don't even think of computing, any kind of scenarios, when you get too many units involved, it's going to be very hard if you need to grow up and grow down. But if they are independently kind of managed, is that much easier to grow up and down, or have it kind of flexible in elastic is what I'm trying to say. So, and then another benefits of Pulsar too, a feature that it has is geo-replication, and it's very native to it too. If you kind of take a look in here, this diagram is that over here, there's like different topics, and they all kind of well, actually, I'm sorry. Let me kind of start again. I should say geo-replication are kind of important if you are in scenarios in which you have like many data centers that are scattered everywhere, right? They are like in different geo areas, and they have different business rules and things like that. So you can actually do replication between these different data center quite easily within Pulsar. And there are certain things you don't want to replicate necessarily across different regions. For example, I was talking about here in Europe, there's GDPR, but in US, we don't have such, or maybe other regions have some other things. So you can configure it so then only certain data can should be replicated across different region, things like that. So selective message replication, and you can also do replication while the system is running too. So all of these modes that are active active or active passive to synchronous way or asynchronous, and it's very flexible to do this geo replication. And then another feature about it is it being like multi-tenancy. So essentially too, I think I already kind of talked a bit about with the Dublin folks here, but let me repeat, to you, but also to the audience, that multi-tenancy is essentially to allows you to manage your data in a more lets you organize your data in a more organized fashion in terms of different tenants. So think of like an apartment building, you have different units, right? So each unit is independently operated. You have your own kitchen, your bathroom, or your plumbing system, whatnot. So multi-tenancy, in some sense, right, for the data, how you manage it is kind of a similar concept, because you can have different, data being grouped according to their different needs, but yet each individual units are self kind of sustaining, but they all operate within underneath the same pulsar cluster, that type of stuff. So it kind of it is a very powerful feature in here too. As you can see, right, there are like different. I think the benefits, business benefits, would be reduce your total cost of ownership, and all of these quotas you can set them across the board or however you want. How do you want to manage your flow control and throttling? All of these things you can kind of handle it quite easily to using this model. And then, okay, and then this is the one that I kind of talk about, message queuing. Essentially, too, in Pulsar, you can have, from this, we're talking about from the subscription side. So you can have, as you can see, there are 4 modes of subscription that Pulsar supports. The very top one is called exclusive mode. So this can basically restrict a topic to be only subscribed by one consumer. So in that case, you can think of it as like message queuing, kind of in a sense, right? Not quite exactly, because you still don't need to worry about the address of your receiver. But still, the way Pulsar works is that that subscription only allows for delivery to only one and only consumer. So that's exclusive mode. And then you might say that, well, what if the consumer goes away? I'm always worried about it. So you can then use a failover type of mode, and essentially too, it's also one-to-one, but you can have multiple consumers, and only one is the primary consumer, and then the rest are kind of subsidiary. So then if the primary one goes away, then somebody else from the pool will be picked, become the next primary one to receive the messages. So in a way, then you turn Pulsar into like a message queue in this case, if you use the subscription mode. And then there's also shared mode and also key shared. The difference is that share mode and key shared too, you can have more than one consumers too in those subscription mode. But the shared is that it doesn't guarantee the ordering of the messages as they arrive. You don't necessarily have to guarantee their order. But for key shared is where you actually want to make sure the messages gets delivered according to when they get delivered, or kind of comes in. You want to make sure they deliver in the order it was sent to. So those are the different subscription modes. Okay, so this is kind of a couple of Pulsar developer features. So when we talk about Pulsar, we allow you to develop, data pipeline. So if we kind of think of, data pipeline, very often we're then talking about Pulsar functions. And if I have to describe it, I can kind of talk about functions. It's like, or we can describe the data like it is like water flowing through a pipeline. So over here, right, we look at a faucet that's kind of source of the data that generates the data. Data flows through some pipeline, and then eventually too, it goes through this one kind of system in which there may be measurements, different way of filtering impurities from the water, all of these things. So that's kind of likened to Pulsar functions. And essentially you kind of, massage the data, do whatever you need. When it's done, then you output the data to a sink. So as you can see over here, it's just a picture of a sink, and that's where you collect all the cleaned or massage kind of output of your data. That's the data pipeline. So in Pulsar, we have Pulsar functions. So that allows for very complex streaming processing. You can actually have different like data pipelines having like different multiple source and then sink and all kind of connected in kind of a chain too. But the idea of a Pulsar function is that It allows for complex streaming processing and it's very lightweight, and it functions as a service. So if you kind of think about it too, you can write your transformation function. You deploy it, you only deploy it once. And it's basically, if your system grows and shrinks and all of these things, the Pulsar function will also be taken care of. It will be deployed accordingly when your system grows and shrinks. So that's kind of like one kind of good thing about it. And besides, you don't need to worry so much about using any other kind of external libraries to help you to transform your data. So that's kind of Pulsar functions in kind of a quick nutshell describing what it is. Currently too, with Pulsar though, it's only supporting Java, Python, and Go, but there are more community efforts into kind of increasing support for more languages too. So. And then there's also a feature called Pulsar schema. So anytime we're doing message transfer, sending from point A to point B and have to go through the wire, is that we have to, as we all know, we're Java developers, right? We know we need to flatten your structure, right? You need to deserialize your data. So deserializing, okay, so you can do it yourself and then transform the data. If you don't use any schema, you have to transform it to byte array. So it's a bit more primitive way of dealing with things. And what if your data changes, right? Then every time you need to write your code again to take care of changes of your structure of your data. So you can actually use Pulsar schema. So that's another feature in there. And the schema, it supports all types, right? Primitive types or key value pair, JSON, Avro, and protobuf, all of these popular kind of structure of data format. So, and also too, not only that, if you use Pulsar schema, it helps you to also keep tracks of your version of the different data as it changes through time too. So it manages the changes of your change of schema. And then also all of these, the management can be automatic or manual too. So it's kind of a nice feature that Pulsar offers you if you don't want to kind of deal with the deserialization and serialization directly yourself. And then this also too is another feature is Pulsar IO. It basically allows you to build your own connectors. So as you can see, right, we're talking about source, and what kind of source, right? You might be asking. Yes, you can actually have, for example, like database, right? You can have Oracle database or Cassandra database. These can be your source of data, right? And can be Kafka, can also be a source. So the way Pulsar is working is that it has some pre-configured connectors, and they're kind of already like couple, I guess like 100 of connectors already. And then of course DataStax too, we support them in our managed cloud platform, but we're also increasing the number of supported connectors every day to their source, and also likewise to the sync side. So for the sync side is probably more popular, would be like in Elasticsearch Sync, for example. That's already pre-configured. You can use it kind of out of the box. Okay, so that's that. And DataStax flavors of Pulsar, I just want to quickly kind of bring to your attention. Pulsar meets you where you are. So we're saying, so to speak. So there's Astra Streaming is our DataStax like managed cloud platform that is already, you can run Pulsar already on the cloud. And we offer also a $25 credit too, if you want. And then there's also Luna Streaming. If you don't want to use our cloud, you can launch it onto your own cloud too. It's Luna Streaming, but there's also like enterprise support too. And then there's also open source way. If you want to use completely open source, you're welcome to too. And then also too, Pulsar, we call it as the messaging substrate. You can use Pulsar natively, or if you have a RabbitMQ backend or Kafka or JMS, we actually have API called Starlight API that you can connect to these different messaging kind of systems too. And here too is basically wanting to kind of let you know, right? It's not like telling you to buy it, so to speak, but basically you can manage your own using Luna Streaming. There's also a change data capture feature for Cassandra that works, essentially leveraging on Pulsar too. And these are, you can use Luna Streaming with the CDC for Cassandra, or you can use our Astra Streaming, which is the managed cloud platform that also has change data capture for Astra DB. Astra DB is our Cassandra, the managed cloud, managed Cassandra cloud too. So, okay, so this one too is just like a quick description using all of these companies' logos to describe to you. These are the very rich ecosystem of connectors and clients that as of January this month, pretty updated too. As you can see, we support a lot of different databases. I bet the ones that you're using are already supported here. And then not only that, there are also some SaaS platform, like services or software as a service platform like Twitter or Canal or SAP. All of these supported Apache Kinesis. And then there's also monitoring observability like Datadog and New Relic and Splunk, all of these things, and the number of connected again, or supported connectors and clients are increasing too. And the language clients, as I described, is Java, Node.js, and Scala, Go, all of these, as you can see, Visual Basic too, and also like C++, and then C Sharp as well. Okay, so now I think I have like about 5-10 minutes. Is there any question? I'm sorry, I kept talking. Not sure if folks have questions. I think I don't see any questions here. Or good? Yeah, all good. Okay, then I can kind of go to my quick demo. Or I guess Neha didn't say anything, so I will just go ahead with my demo. I have to switch over here. Okay, so as I mentioned about DataStax as a managed cloud platform called Astra DB. So you're all welcome to sign up for it too. Over here, this, if you sign up, and it's basically you don't need to give your credit card to, and you can quickly sign up for it. And I think I see somebody asking a questions. Oh, okay, somebody is saying, I think, okay, I don't know how to say your name, but the handle. Is there any demo application? Yes, so I'm going to be doing a quick demo here. This is using the managed cloud platform that DataStax has, and it's called Astra. And right now it's still called Astra DB, but there's also support of Pulsar running on the cloud too, so you can log on the same. And so in my case, right, I already have an account, so I can do it again. Sometimes it gives you some trouble, but let's say I already have an account. So hold on, sorry, it's taking a little bit of time. So okay, so I hope you can all see. So as you can see, right now I actually haven't used up my credit. I have $25 in here, and as you can see in here too, if you want to, even now, if you want to play around with Cassandra, you can do a create database, and these are already a bunch of databases that I've created, and you're welcome to do it. Now, today we're talking about Apache Pulsar. So if you don't want to install your own on your laptop, or don't want to bring up a Docker on your laptop or system, you can do a create stream over here. And then I talk about it's a multi-tenant system. It's already, we're managing all of your systems like tenant base. So I can just say JChamp, for example, and then I want it in maybe Google Cloud, and then this is in Europe West. Actually, it should be Europe. Yeah, it is West. Okay. And then as you can see over here, it shows you too, like how much the operation costs is actually, very small, the amount. And then you can then create your tenant. Now, I'm not going to create now because I already have a couple tenants, but I do want to quickly kind of show you. If I go back to the dashboard, let's say, right, let's say I pretend, right, I'll use one that's called Comash, which I actually went to 2 weeks ago. So over here, that's why I like to suggest folks to try out this Astra platform. It doesn't cost you anything, and we don't like email a lot, to bother you too. But I think it's just a nice way for you to get used to this platform in a very quick way. So you don't need to install things. You don't need to, kind of run a Docker, for example, on a Docker desktop, for example. It's just very easy. So let's say, for example, I want to, you come up in here. If you go to quick start, it will guide you. How do you get started with Astra streaming? How do you create a topic? All of these, you can follow this along too. And then over here, I'll just go to the connect, right? You can connect to your tenant in a few different ways. So let's say this is a Java user script, so I'll do Java. And then over here too, you can basically use this interface, and it already gives you the information, very basic, right? How do you how do you specify in your Maven dependency section, or using Maven or using Gradle? Everything is there. And then how do I write a producer? You can actually kind of take a look in here too. And so let's see how much time, about 5 minutes. So just real quickly, as you can see over here too, if you want to get a quick start, you can follow this along. And if you want to also look at other languages, as you can see up top, right, there's also not just Java, but there's also like Python or Go, Node.js, JMS, all of these too. We have them available. And if you need more information, I'm always here, or contact us on our DataStax developers at Discord. Somebody will be there to help you. So all of these things, you can kind of take a look over here. In order to set up your producer, you just public class. For example, here's simple producer. And then you can then use your service URL is already generated for you too, as once you set up your cluster in this case. And then this is just a very quick example of showing you. So a couple of steps is create your client object, right? Pulsar client builder, and then you just connect your service URL and also your authentication token too, and that's all being generated for you too. So I'll quickly show you where to get them. And then once you set up your Pulsar client, then you can set up your producer to produce the client, doing like a producer equals client dot new producer, and then basically then call set up your topic too, and then pass in your topic name and do a create. Then you are all set to go. At that point, you can start sending messages using producer.send. Of course, this is kind of a very simple case, but in reality, I'm sure you will need to design your system accordingly. But this is kind of the basic how you do it. If you want to send it, in this case, if you do a send call, this is synchronous call, but there's also asynchronous call too, for example. And then when you're done, you just close them and then you're all done. So this is like a producer code, in a very quick nutshell. And in consumer side too, also, it's not that complicated. And just like producer, you basically have to set up your client first and then give all these parameters, your service URL. That one will be your broker, right? That's running in the cloud in this case. And then pass in your token. With that, then you can then do a consumer, you set it up client.new and then connect to your topic, and then basically do then you give it a subscription name. And if you need different subscription mode, right? Like I mentioned, there are 4 subscription modes: exclusive, or failover, or shared or key shared. And so you pick your one if you need. If you don't, I think it's set up as an exclusive kind of mode too. And then you can then do a subscribe. Now, at that point too, if you run this code, if you have not produced data, you won't see anything. So you do need to keep your consumer running. So once there's data arrive in your topic, then it will be sent to you. So that's how it works. And I think I only have 5 minutes or so I won't get into all the detail. And then as such too, this is all is needed. So as you can see, it's not that difficult to start, right? So I encourage all of you to give it a try. And then not only that, there's a producer consumer, and one thing, there's also CDC, the change data capture consumer. We also give you example, how do you build a simple pipeline and then output it to your sync, all of these things too. And also, there's also a reader interface. So that allows you to traverse your log messages. So as you can see, right, you're sending tons of messages. How do you access it, right? And you basically can use a reader interface to kind of navigate and get to your messages. Because all messages are sent, they are all being stored for you too, in that case. Okay, so I think I only have 3 minutes, so I won't kind of continue talking, but let me go back over here and get back to my over here. Okay, so just to share with you all of the resources and links. Not all are included, but these are the major ones, right? Pulsar, Bookkeeper, Zookeeper, and all of these are DataStax information over here. If you want to sign up for our free or the free $25 credit, is go to astra.datastax.com. And the rest, there are different links to different Astra streaming or Luna streaming or our CTC information. And then if you want to have extra credit, you can also sign up using this QR code or this link to get additional $200 in credit too. Otherwise, you get $25 per month, and then it gets renewed, per month too. So it's new. It's nice. This one is a link to our DataStax developers. If you want to get additional information about Pulsar, we've recorded these 5 minutes about Pulsar, and we're continuing working on it too. And then this is my Twitch stream. If you like to follow me, it's every Wednesday. If I'm not traveling, then I would normally do a stream. And then this is a link where you can get additional training information if you're interested. It's our awesome Astra site too. And then these are Pulsar community information. If you want to this is our first one, Apache Pulsar neighborhood is our wiki page. We have information you can contribute. Anybody can contribute to that. And also if you want to join the Slack channel too, is here. And with that, I want to thank you all. I think I'm not too much over time, not yet, a minute. So thank you. Thank you very much. And I really appreciate it. So.
Thank you, Mary. Thanks a lot.
Thank you, Neha. Thank you. Yeah, looks like baby is saying something.